we are going to look at some common functions and the shapes of their graphs. So we're going to first start with lines. And we know that with the equation of a line, we typically talk about the y equals mx plus b format. Now, when a line is a function, there are three possible graphs that you could have. So you could have a diagonal line that goes up from left to right. This is going to happen when your slope is positive, and our slope is our m value. You could have a line that goes down from left to right. This occurs when your slope is a negative value. And then finally, you could have a horizontal line, and that occurs when your slope is 0. We do not include vertical lines here because we are only talking about functions. Okay, so the second type of shape that we're going to talk about are polynomials. And there are two basic types of graphs. And so we get either something that we consider a U-shaped graph or something that we consider an N-shaped graph. Now, with a polynomial, you have y equals a, which is just some coefficient, and then you have a x raised to a power. And if that power happens to be even, that is when you will have U-shaped graphs. Now, there could be lots of other terms, so we'll just say plus dot dot dot, and you're only looking at that highest power of x. So if that power is even, we say you have a U-shaped curve. Now, it could be a perfect U, or there could be lots of wiggles in between. The main thing is the ends are both going either up or down, like they would on the letter U. So if that coefficient of A happens to be positive, we say the U goes up. When the coefficient of A happens to be negative, that is when we say the U is going down. And so again, the key there is the fact that you have x being raised to an even power. So things like x squared, x to the 4th, x to the 6th. Okay? All right, so when x is raised to an odd power, so you have your some coefficient, x to an odd power, and again, there could be lots of other terms. The main thing you're looking at is the highest power of x. And you're only looking at powers that are greater than or equal to 3. So we're not talking about a power of 1, because then that would put us back at a line. So powers of x that are greater than or equal to 3. Then you get what we consider an N shape. And the main reason we call it an N shape is because of what happens with the letter N. Like here, it's going down on the left and up on the right. So this graph could look something like this. And there could be lots of other things in between there, but it's going down on the left and up on the right, or it could be a backwards N where it's going up on the left, and again, lots of squiggles in here, and down on the right. And the difference comes with your A. So if your A is positive, we say it's a forwards N. If your A is negative, that's when we say it is a backwards N. So again, what you're looking for is you're looking for x being raised, in this case, to an odd power. And that's what gives you the N shapes. X to an even power gives you the U shape. Okay, so the next type we're going to talk about is absolute value graphs. And on the absolute value graph, we consider this a V-shaped graph. Okay, so with the actual function, again, A is just a coefficient, and then you have the absolute value of your variable x. And so you're either going to get a V that opens up, or you will get a V-shaped graph that opens down. And just like with the other ones we've talked about, it depends on your A. So when your A is a positive number, the V will open up. When your A is actually a negative number, then your V is going to open down. Okay, so the next type we're going to talk about are our radical functions. And there are two different shapes in this case that we will talk about. So we're either going to get what is considered a half U on its side, or we're going to get a shape that is an S-shaped graph. So let's look at what the equations look like. And so y is equal to, A is a coefficient, and you're going to have x, and if it's written in rational form, it could have a power like 1 over 2, or 1 over 4, or 1 over 6. In other words, 1 over an even power. Or if it's written in actual radical form, you'll still have that coefficient, and what will happen is you'll have some even root right there as part of the index. So things like square root of x, fourth root of x, sixth root of x, okay? And so in this particular case, you'll either get the top half of a U going from left to right, like that, opening up, or I'm sorry, opening to the right, or you'll get the bottom half. And what determines that is your A. So if your A is positive, you're going to get the top half. And if your A is negative, you're going to get the bottom half. Now, in the case where you have odd powers, so in terms of the equation, you'll have some coefficient A, and if it's written in rational form, you'll have x raised to a power of something that is 1 over an odd number. So things like 1/3 or 1/5 or 1/7. We don't talk about odd powers that are equal to 1 because, again, we'd be right back at a line. So these are odd powers that are greater than or equal to 3, just like before. Or if it's written in radical form, you'll still have that coefficient out in front, but you'll have some odd number that's part of your index. So cube root of x, fifth root of x, seventh root of x. And so in this case, we get what looks like S shapes in terms of our graph. And it's more like it's stretched out. So, you know, kind of like the S goes to the right at the top and left at the bottom. Same thing there. Or it could be a backwards S, which is almost like the letter Z. And so, just as usual, what determines this is your A. If your A is positive, you get the forwards S. If your A is negative, then you get your backwards S. All right, so the final types of functions we'll talk about are the rational functions. And we refer to this as your two pieces graphs. So these graphs have two pieces. All right, so let's first look at the different types of equations. Now, what you'll notice on these is that x is going to be in the bottom of a fraction. And so if it's in the bottom and it's got an even power, then we refer to the two pieces as next door neighbors. So the pieces are neighbors. So your graph is either going to look like this, where both of your pieces are in quadrants 1 and 2, or your graph is going to look like this, where the two pieces are in quadrants 3 and 4. And just like you may have guessed, A is going to determine where those two pieces are. So if your A is positive, your two-piece neighbors include the first and second quadrant. Whereas if your A is negative, then your two pieces are going to include quadrants 3 and 4. Okay, so then the final thing that could happen is you could, again, have the x in the bottom, but instead of an even power, it has an odd power. And that would include powers of 1 as well because of the x being on the bottom. And so when this happens, I like to say they are not neighbors. They are not neighbors. And so you get one of two graphs. You either get a graph that has a piece in quadrants 1 and 3, or you're going to get a graph that has pieces in quadrants 2 and 4. And so once again, your A determines that. If your A is positive, you're going to have quadrants 1 and 3. If your A is negative, you're going to have quadrants 2 and 4. So let me point out a few things there. So when your A is positive, notice in either case, you always include quadrant 1, which is the quadrant where both values are positive. And then, if you know whether they're neighbors or not, that will automatically tell you where that other piece is. All right, so then the other thing I want to point out is just kind of just a silly way to remember it. If you think of the word odd as an adjective, you think about, I don't want to live next to an odd person. So you don't want to be their neighbor. So when you hear the word odd, think of not neighbors. Whereas, you want to live next to a cool person. And sometimes we, if we think somebody's cool, we think of them as being just kind of, even in terms of their personality. So even people, we want to be their neighbor. Odd people, we don't want to be their neighbor. So that's just kind of a silly way to remember it.